66 million years ago, on a day like any other, the most successful animals the planet had ever produced were going about their lives. A Tyrannosaurus rex was tearing flesh from a carcass in what is now Montana. A pack of Dakota raptors was stalking through fern undergrowth along a riverbank. An Edmontosaurus herd was grazing across a floodplain that stretched to the horizon. Triceratops were locking horns in a dominance display while pterosaurs circled overhead. The world was warm, the forests were thick, the food chains were stable. Dinosaurs had ruled this planet for over 160 million years, and there was no reason, no biological reason, for that to end. And then, in the space of a few seconds, everything changed. A rock roughly 7 miles wide entered Earth's atmosphere, traveling at approximately 44,000 miles per hour. It did not slow down significantly. It did not burn up. It crossed the entire sky in a matter of seconds, and when it struck the shallow seas off what is now Mexico's Yucatan Peninsula, it released energy equivalent to over 10 billion nuclear bombs detonating simultaneously. The impact created a crater over 110 miles wide and 12 miles deep. The asteroid itself vaporized instantly. So did everything within a 100-mile radius. The ocean floor was punched open to the mantle. A wall of superheated rock, gas, and steam erupted upward faster than the speed of sound, punching through the atmosphere and into space. Within the first 60 seconds, the energy released by the impact sent a shockwave through the Earth's crust. The ground moved like liquid. Earthquakes, not like anything in human experience, but magnitude 10 or higher, rippled across the planet. Every fault line on Earth activated. Volcanoes that had been dormant for millions of years cracked open. The tectonic plates themselves flexed. The seismic energy was so extreme that rocks on the opposite side of the planet, in what is now India, shifted and fractured. Some scientists believe the impact intensified the already active Deccan Traps volcanic eruptions, which had been pouring lava across India for thousands of years. The planet was being shaken apart from the inside. Within the first 10 minutes, a mega tsunami formed in the Gulf of Mexico. This was not a wave in any ordinary sense. It was a wall of water over a mile high, traveling at the speed of a jet aircraft. It swept across the Gulf, scouring the ocean floor, ripping up sediment hundreds of feet deep. When it hit the coastlines of what is now Texas, Mexico, and the Caribbean, it pushed miles inland, flattening everything. Fossil evidence shows marine creatures, sharks, ammonites, fish, were found deposited hundreds of miles inland, mixed with shattered trees, rocks, and dinosaur bones. The water did not just flood the land, it rearranged it. But the most devastating effect was happening overhead. The impact had launched billions of tons of rock, dust, and vaporized material high above the atmosphere. Within hours, this material began re-entering the atmosphere on the opposite side of the planet. As it fell, friction heated the particles to extreme temperatures. The sky caught fire. Not metaphorically, the thermal radiation from trillions of re-entering particles raised surface temperatures worldwide to oven-like levels. Forests ignited spontaneously. Animals with no shelter, anything in the open, were cooked alive. The entire surface of the Earth experienced a pulse of heat equivalent to standing inside a broiler. Studies of soot layers in the geological record suggest that over 70% of the world's forests burned within days. The smoke alone would have been unimaginable. A black wall of ash and carbon rising into the atmosphere from every continent simultaneously. Now imagine what this meant for the animals alive at this moment. A Tyrannosaurus rex standing in what is now North Dakota would have seen a flash on the southern horizon brighter than the sun. Minutes later, the ground would have begun shaking, violently, continuously. The shaking would not stop. Trees would have been falling, riverbanks collapsing, the landscape warping. Then the sky would have started to glow, first red, then orange, then white hot as re-entering debris turned the atmosphere into a convection oven. The T-Rex could not outrun this. Nothing could. Even if it survived the initial heat pulse, perhaps sheltered in a cave or near water, what came next would have sealed its fate, because after the fire came the darkness. The smoke from the burning forests, combined with the dust and sulfur blasted into the atmosphere by the impact, created a shroud around the entire planet. Within weeks, sunlight was reduced to near zero at the surface. Temperatures that had been warm and tropical plummeted, not gradually, catastrophically. Global temperatures may have dropped by as much as 25 degrees Celsius. The planet went from greenhouse to deep freeze in a matter of months. Photosynthesis stopped. plants died. The base of almost every food chain on land and in the ocean collapsed simultaneously. Anything that depended on plants, which was almost everything, began to starve. This is the part of the extinction that people underestimate. The asteroid strike itself lasted seconds. The earthquakes, tsunamis, and firestorms lasted hours to days. But the darkness lasted years. Some models suggest the impact winter persisted for a decade or more. For 10 years, the sun was a dim smudge behind a sky of ash. Rain, when it fell, was acidic. Sulfur compounds from the vaporized rock had combined with water vapor to create sulfuric acid rain that poisoned soils, rivers, lakes, and coastal oceans. The pH of surface water dropped to levels that dissolved the shells of marine organisms. Coral reefs collapsed. Plankton populations crashed. The ocean food chain, which had supported marine reptiles like Mosasaurus and the giant fish-eating pterosaurs, simply ceased to exist. On land, the situation was equally catastrophic. Large herbivores, Triceratops, Edmontosaurus, the titanosaur sauropods, could not find enough food. The plants they depended on were dead or buried under ash. They starved first. Then the predators that hunted them, Tyrannosaurus, Dakotaraptor, the smaller theropods, lost their prey base. A full-grown T-Rex needed to consume enormous quantities of meat to survive. With prey populations collapsing, starvation was inevitable. There was no adaptation possible, no behavioral change that could compensate for the fact that the food simply did not exist anymore. The largest land predators in Earth's history were reduced to scavenging carcasses in a frozen, sunless world. And even the carcasses ran out. But not everything died. And this is perhaps the most important part of the story. The survivors were small. They were burrowers, seed eaters, insectivores, scavengers. They were the creatures that could hide underground, survive on minimal calories, and wait. Small mammals, most no bigger than a rat, survived in burrows, eating seeds, roots, fungi, and insects. Some freshwater turtles and crocodilians survived because they could slow their metabolism and live in water that retained heat longer than the air. Some birds, the direct descendants of small theropod dinosaurs, survived, likely because they could fly to find isolated pockets of food and because their small size required fewer calories. Frogs, salamanders, and some snakes survived for similar reasons. The pattern was brutal and clear. Size killed you. Being at the top of the food chain killed you. Needing large amounts of food killed you. Specialization killed you. The very traits that had made the dinosaurs the most successful land animals for 160 million years, their size, their power, their dominance, became death sentences in a world where the rules had changed overnight. The recovery took millions of years. For the first 100,000 years after the impact, the world was a wasteland. Fungal blooms dominated the landscape, feeding on dead organic matter. Fern spikes appeared in the fossil record, as ferns were among the first plants to recolonize the devastated land. Slowly, forests returned. Flowering plants, which had been a relatively minor part of pre-impact ecosystems, exploded in diversity during the recovery. The mammals that had survived began to diversify and grow. Within 10 million years, the first large mammalian predators appeared. Within 20 million years, the ancestors of modern whales, horses, primates, and carnivores were spreading across the globe. The age of the dinosaurs did not end because they were failures. It ended because the planet itself was broken. Violently, suddenly, and completely. The most powerful, most dominant, most successful land animals in Earth's history were erased not because something better replaced them, but because a rock from space rearranged the rules of survival in a single afternoon. And the small, forgotten creatures hiding in the dirt inherited everything. Today, the Chicxulub crater lies buried beneath the Yucatan Peninsula. You can stand on the ground directly above it and see nothing, just flat limestone and jungle. The ocean has reclaimed the impact zone. The forests have grown back. 66 million years of evolution have covered the scar. But beneath the surface, the ring structure of the crater is still detectable. Core samples pulled from the site contain shocked quartz, tektite glass, and iridium, the chemical fingerprint of an extraterrestrial impact. The evidence is unambiguous. This happened, and it happened fast. If you could go back to that last normal day, 66 million years ago, and stand in the forests of late Cretaceous North America, you would see a world so alive, so dense with enormous powerful creatures that the idea of it all ending in a single day would seem impossible. Tyrannosaurus rex had no predators. Triceratops had no equal. The ecosystem was locked, balanced, ancient. It had survived ice ages, volcanic eruptions, sea level changes, and continental shifts for tens of millions of years. It was, by every reasonable measure, permanent. And then it wasn't. That is what makes the Chicxulub extinction the most important event in the history of life on Earth. Not because of what it destroyed, but because of what it proved. That no amount of strength, no amount of dominance, no amount of evolutionary success can protect you from a sudden, total change in the rules. The dinosaurs did not fail. The world failed them, and in the silence that followed, something small, something overlooked, something that had been hiding in their shadow for 100 million years finally got its chance. We are that something.